I forgot all day today. I forgot the whole first part of all day, all my classes today, so thank you. So for any given function, there's always an input and output value. An inverse of a function is what will undo the function, and it will turn the output values back into the input value, which is kind of a weird statement. So what I did is I went and found some notes from another teacher, just put in a different way than what I did. So we're just going to do it just kind of in a different way. Same way, different words. So that's what we're kind of doing today. So we use the notation F inverse of x to indicate the inverse of a function. It reads the inverse of f. Consider the function f of x equals x minus 2. What would you do to undo this function? So to undo x minus 2, what do I do to undo that function? This is a really easy one, right? So to undo this function, what do? Well, I add 2 to both sides, right? So then it says, therefore, the inverse of f would be x plus 2, okay? So just because that's a simple one, that one's pretty easy. So the next 4 questions are pretty easy. Why don't you guys fill in these blanks for me in the chat box, please. The inverse of addition is, the inverse of subtraction is, the inverse of multiplication is, and the inverse of division is. Please. So you guys are doing great. Everyone who's put in an answer so far has got them right. So the inverse of addition is subtraction. The inverse of subtraction is, really? Is addition. The inverse of multiplication is division, and the inverse of division is multiplication. Right? You guys all knew that. Okay? Everyone who's put it in there got it right. Good job. Okay? Awesome. All right. So then they give us an example of a harder one instead of the one that they gave us in the little first definition. So find the inverse of f of x equals 3x plus 4. So step 1, we write y instead of f of x. Okay. Step 2, switch the x and the y, which we already know. So they switched the x and the y. So here was the x, and then it became over here the y, and they switched those around. Okay. And then they solve for y. So I subtract 4, divide by 3, and I get x minus 4 divided by 3. And then instead of writing y, we write the inverse of f. The inverse of f. What notation did they use? Sorry. The little -1 should not be there. It should be, this is what I get for not paying attention. It should not be there. It should be here. F inverse of x. Okay? We've done this. We did this Friday. I wanted to go over how to do it, so we have some extra practice just to make sure that we have it down solid in our brains. Okay? And some of you have already done the checkpoints, but if you didn't get a good score, you can do it over again, which is fine, because I think you have a couple chances to do it. So we're going to do the inverse of h of x. And we're going to do these 2 together. And then we have another example of points, and then we'll do those ones. And then you guys will have some practice time. And then we'll have some time to talk about what the lesson is, the homework is, the assignment is today. Wow. Okay, so we know that h of x is y. And then I'm supposed to replace the x and the y. So that means I've got x equals 3 halves y minus 4. Beautiful. Okay, so I want to solve for y. I want to get y by itself. So the first thing I'm going to do is add 4. So that gives me x plus 4 equals 3 halves y. Now I need to get y by itself. So what am I going to do? Oh. So what do I do to get y by itself? Well, I'm multiplying by a fraction. So how do I undo a fraction? I multiply by its reciprocal, and that's where I take the fraction, right, and I flip it. So instead of 3 over 2, it becomes 2 over 3. So I'm going to multiply this whole thing by 2 over 3. So what's our, it's h. So that means h inverse of x, that's what y is, okay, is going to equal 2 times x plus 4 divided by 3. I'm just going to leave it that way, okay? Is there any questions? Just kind of remember this. Erin Denny, I did get your message, by the way. I'm sorry, as I saw your name, I remembered you sent me a message. Yes, I can reopen that for you. I've just been crazy busy this morning, so I will get it open as soon as we get done with class. So
thank you so much. I appreciate it.
You're so welcome. I just wanted to, I saw your name. I was like, oh, I haven't responded to her. So I'll get that taken care of for you today. Okay.
Thank you.
You're welcome. Everyone good with that question? Can we go ahead and go on to the next one? Okay. Maybe I can slide over here. Here we go. So we're going to do exactly the same thing. Find out where y is, which is c of x in this case. So this is y. And then I'm going to switch my x and my y, right? Oh, Jacqueline and Celeste. Jacqueline's already been in here. Here's Celeste. Okay. So I'm going to switch my x and my y. So this becomes x equals the cubed root of y plus 3. So I need to get the cubed root by itself before I can do anything with that. So I'm going to subtract 3. And I've got x minus 3 equals the cubed root of y. And how do I undo a cubed root? Anybody? Marco. I can do a cubed root by cubing it. So I'm going to cube it. If it was a fourth root, I'd fourth it. Wow. Okay, I'd take it to the 4th power. If it was a square root, I'd square it. Okay, whatever this little root is here, that's what power I would take it to. And if I cube it on one side, I've got to cube it on the other side. And then because the cube undoes the cubed root, I've got y by itself. So I've got c inverse of x equals x minus 3 cubed. And that's it. Done. Oh, no, you're fine. You're fine, Jacqueline. People have been having problems all day. Okay, so don't worry about it. I'll just keep letting you back in. It's not a problem. Okay, questions on that? Jessica, you're okay with it being cubed instead of squared? Does that make sense? Why it's square, cubed? Are we good? Tony's here now. Okay. All right. So we're going to go ahead on to the next page here. Okay. So, and it says the top is just a little directions or a little sample. Wow. Example of how to find it if I have an ordered pair. So to find the inverse of an ordered pair, we simply reverse the order. So if I had my ordered pairs are x, y, and to find the inverse, they become y, x. So I just switched the x and y, which we already know. So if my function was 3, 9, negative 3, 1, and 0, negative 4, my inverse function would be 9, 3, 1, negative 3, and negative 4, 0. I just switch it. So anything that would give me an ordered pair, such as a table, a mapping, or a set of ordered pairs, anything like that, that's all I do is I take my x and my y and I switch it. So I'm going to have you guys do the next two. So we're going to do these in sets of 2, I think. Yeah, let's do these in sets of 2. So, shoot, forgot to record. You guys were all putting them into the chat box, which is correct. as 6, 8, -1, -3, 11, -5. Oops. Cut off my 11. There we go. And 7, 4. Beautiful. That's awesome, right? Just switch my X and my Y. Okay. So now let's talk about number 2. A few of you got this right. A few of you. Nice, Malia. Okay, a few of you, not sure what happened, but we're going to work on it. So if I call this Y, and then I switch my X and the Y, so I've got X equals 3Y minus 2 divided by 5. I've got to solve for Y. So the first thing I have to do is get rid of my fraction. Well, how do I get rid of my fraction? I multiply by 5. So that 5 goes away, and I get 5x equals 3y minus 2. And then I'm going to add 2 to both sides. So I get 5x plus 2 equals 3y. And then I'm going to divide by 3, and I think this is called f. So f inverse of x is going to be 5x plus 2 divided by 3. Done. Or you could have written it as... some people wrote it as 5. Oh, that is not a 5. Let me try that again, ladies and gentlemen. Let's see. 5 thirds x plus 2 thirds. That's fine too. However you want to write it. Okay? Nice job. Okay. So now we're going to go to the next 2. So let me put that up there. Okay, so here we go. We're going to talk about finding the inverse of G, right? So I'm not sure. Look, I'm not sure. I'm not sure what some of you guys are doing. So remember, I switched that. This is Y, right? The first thing I'm going to do is switch my X and my Y. Okay? Switch my X and my Y. So this becomes X equals Y squared plus 2. So I've switched the X and Y. Make sure that you're switching it. Okay? Make sure. And then I'm solving for Y. So I'm going to subtract 2. And then I get X minus 2 equals Y squared. How do I undo a square? Well, you square. Yep, I square root it. Yep. And if it was a cube, I'd cube root it. If it was to the 5th power, I'd 5th root it. Whatever exponent is here will go in my little root thing. Just like, oh, it wasn't on this one. It was on the other page. Just like if I have a cubed root, I'm going to do whatever root would be that would become whatever my exponent is. So these two things here have to match. So I square root one side, so I have to square root the other side. So I get y, the square root of y squared is y, which would be g inverse of, I think that's a g. Yeah, it looks like a g. G of x equals the square root of x minus 2. So a square does not undo a square. I hope that helps out a few of you when you were doing that. Just let me know if you have any more questions. And then this is just a point. So what am I doing? I'm just switching them, right? So I've got 1, 2, and 5, -3, and 8, -1. And this one's super hard. 2, 2. Okay, questions? Yes, no, maybe so. Everyone's okay. Okay, 2 more. Oh, didn't realize that little page didn't make it over there.
Word.
Yeah, I did. Got it. Thanks. Thanks, Mel. Switch the X and the Y, so this becomes a Y. And then I've got X equals 1/3 Y plus 5. So subtract 5. So I've got x minus 5 equals 1/3 y. So I'm going to multiply by 3, multiply by 3. So h inverse of x equals 3 times x minus 5. Divided by 1. I don't have to put divide by 1, but you can. It's fine to put divided by 1 because you're multiplying by 3 over 1. So it's fine to put divided by 1. I'm okay with that, okay? But you don't have to. But you can. Okay. Alrighty. So the number 6, same thing. I'm going to exchange my x and my y. So I've got x equals the square root of y minus 3. So add 3. So I've got x plus 3 equals the square root of y. So this is a square root. There's no little 3 in there, right? It's a square root. So how do I undo a square root? Well, you square it. So I'm just going to come over here as a side note. So if it was the cubed root of y, then I would cube root it. If it was the 6th root of y, then I would take it to the 6th power. If it was the, 15th root of y, then I would take it to the 15th power. Whatever little number is there, that's what power I'm going to take it to. If there is no number there, it's a square root, which means it's 2. Okay, does that help a little bit for some of you guys that were unsure about that? So if there's no number there like this, the square root of y, this is just a little 2. I don't have to have the 2 there. It's just assumed, like if you have an x by itself, that just assumes that you know that it's a 1x. They just assume that you know that this is a square root. So they're not going to put the little 2 there. They're going to assume that you know that this is a square root. Okay? So I hope that helps out a little bit with that. So if I square one side, I'm just going to square the other side. So I get, looks like it's a b. A b inverse of x is going to equal x plus 3 squared. And you can leave it that way. That is not a problem. I can leave it written this way because it's easier to find the inverse if it's in this form and to look back and forth and to verify its inverse. It's just easier to do in this form. But if you decided to go ahead and multiply this back out, you could have said this does equal x squared plus 6x plus 9. So if you wrote it that way, that is fine. But you didn't have to go that far. You could have written it there. Okay? Nice job, you guys. So I wanted to make sure if everyone's okay with the root thing, because this is where most people have issues with, is this thing. And it's true going the other way also. Okay, so now I get to skip this page because it did an extra page accidentally. Okay, so now we're going to talk about how do I tell if I'm given 2 equations, how do I tell if they're actually inverses? And this is where that composition of functions that we learned, that we spent a couple days on learning, comes into play. And it says, if 2 functions are truly inverses, you should be left with only the variable when you plug them into each other. And so verify that the following 2 are inverses. It says f of x and g of x, and I find f of g of x. So I'm plugging g into f, and once I do that, I put g, which is 2x, into x divided by 2, so I get 2x over 2, and the 2's go away, and I get left with x, right? Okay. Or I put f into g, so I'm going to put x minus 2 wherever there's an x, so I get 2 times x minus 2. The 2's go away again, and I get left with x again, okay? So that's how I know. And just so you know, you only have to do that one time. I only have to do this one or this one. I don't have to do both of them. If I verify it one way, I don't have to do it the other way. Once I've done one of them, I've verified it. I don't have to do it both times. So now I'm going to do an example for you, and then you guys are going to practice on your own on the next couple problems. So I've got G and F. So it doesn't matter which one I choose to put inside of each other. I'm just going to go ahead and say, let's find G of F of N. So I'm going to put the second one into the first one. Okay. So I've got 5 plus 1/2 times 2n minus 10. Okay. So I'm going to distribute this half through here. So I get 5 plus 1/2 of 2n is n. And 1/2 of negative 10 is negative 5. And I get left with n. And so then they're inverses. Yes. They are inverses. Because I get left with only the variable. Okay? Okay. So now I'm going to have you guys try it. I need you to just tell me by verifying if they're inverses or not. So all right. So when I do this, I'm going to go ahead and do it both ways because I don't know which way you guys chose to do it. So I'm going to go ahead and do G of F of X and F of G of X because half of you might have chose to do it one way and half of you might have chose to do it the other way. So I'm going to go ahead and do it both ways so you guys can see it done both ways. Is that okay? So you can see it done whichever way you chose to do it. That's what I meant to say. So sorry. So, yep. Oh, Lord have mercy. Okay, so if I find the first one I'm going to do is G of F of X. So I'm going to do G of 4x plus 3. So that gives me 4x plus 3 minus 3 divided by 4. So 3 minus 3 is 0, right? So I get 4x over 4. Those go away. That leaves me with x. So yeah, they're inverses, okay? So now I'm going to do it the other way in case you guys, some of you did it as f of g of x. So that means I want to find f of x minus 3 divided by 4. So that's going to be 4 times x minus 3 divided by 4 plus 3. So the 4's go away, and I get x minus 3 plus 3 equals x. Again, it just simplifies down to the variable only, so they are inverses. And Paige worked ahead of us because, you know, she's that fast. And she's already done this one, but I'm going to give you guys a couple minutes to work on it so you can work on number 9, and then we'll talk about what you're doing for your homework. In fact, during this break, I might actually just go tell Paige what she needs to do so she can go ahead and start working on it. Maybe you can see what happened. So we'll try that. You're doing awesome, though, so please keep trying like you're doing. You're doing great. So again, I'm going to do both ways because I don't know which way you guys did it. So again, I'm going to do f of g of n, which means I want to find f of n minus 2 cubed. So that gives me the cubed root of n minus 2 cubed plus 2. So the cubed and the cube cancel out. So I should get n minus 2 plus 2, which equals n. Or, oops, sorry. If I do it the other way, if I find g of f of n, that means I'm going to find g of the cubed root of n plus 2. So that's supposed to equal the cubed root of n plus 2 minus 2 cubed, which equals the cubed root of n cubed, which equals n. Okay? Questions? Is everyone okay? Okay. So, let me stop this.